So in this exercise, we are asking that we know what f prime is. F prime is equal to x minus 1 times x plus 2 times g of x, where g of x is what? G of x is some unknown function. We just know it, for instance, is always positive, and let's say it's nice. It's nice so that f prime is also nice. So when I say nice, I mean that the derivative set always exists and is equal to this formula, the derivative of f. All right, so now we know this information and we want to do the following. We want to find the local maximum minimum for this function. Okay, so let's get started. To find the local maximum minimum, what we have to do is we have to find first the critical points, right, of f. Because we know that local maximum, local minimum are critical points. Perhaps a critical point may not be a local extrema, which means local maximum, local minimum, but we know that necessarily that's why we have to look for a local maximum, local minimum in the set of all critical points. So let's get started. Let's do that. So to find critical points, which are called CP of f. So to find them, what we do is we set f prime of x to be equal to 0. So that means that x minus 1 times x plus 2 times g of x is equal to 0. Now, since the g of x, we are given the information is always strictly bigger than 0, that means that the product is going to be equal to 0 when either one of the factors x minus 1 of x plus 2 is equal to 0, which means when either x is equal to 1 or x is equal to negative 2. So now, let's see. So what I can say. So 1 and negative 2 basically are the critical points. So x equals negative 1 and x equals negative 2 are the critical points of f of x. So second step. The second step is to see whether these are also extrema and what kind of extrema are there. Well, what I need to do to understand this is to just draw a quick graph which is going to just discuss the sign of f prime. So I have x here and I'm going to discuss the sign of f prime. Now I know that f prime is equal to, let's see, 0 at x equals 1. So f prime would be equal to 0. And then I know that f prime is equal to 0 at x equals negative 2. Here we go. Also, what else do we know? Well, let's look now at f prime. F prime is equal to like this product, right? So we know that the product of x minus 1 times x plus 2 times g of x. Now, g of x is always positive, great. Now, when x is larger than 1, we know that both x minus 1 is positive and x plus 2 is positive. So, what do I can say? I can say that the function f prime here is going to be positive. So, and also, what can I say? I say when x is less than negative 2, the function is also positive, right? For the same reasoning. And when the function, when x is between negative 2 and 1, the function is negative. Which function? F prime, the derivative of f. Excellent. So let's introduce this using the function f. So what does that tell us about f? Let's just draw and sketch a very, very primitive graph of f of x. So just around the points negative 2 and 1. So what do we know about negative 2? We know that negative 2 is a critical point where the derivative is equal to 0, which means that the tangent line is going to be horizontal. What else do we know? We know that from the left of negative 2, right, which means for numbers less than negative 2, the derivative is positive. What does it mean in terms of the slope of the tangent line to the curve, to the graph of f? Well, it means that the slope is positive. That means that the function does this, right? And then what does it mean, on the other hand, that on the right of negative 2, the function is, the function f prime is negative. That means that the slope or the tangent is negative. That means that the function does this, goes down. And let's see what happens at 1. Well, I don't know where the value of f is, right? But say that say that f is 0, right? And so I know now there is a horizontal tangent at x equals 1. Now, I know that from the right of 1, the function is positive, which means that it does like this. On the left, the function f prime is negative. That means that the function f behaves like this. So, what can I conclude? I can conclude that x equals negative 2 is a local, what do I see there? Goes up and down, local maximum. And x equals 1 is a local, the function goes down and up, is a local minimum. And I'm done. Good luck with similar problems. Bye-bye.